Welcome back. This is the second video in our quadratic functions unit. And during this video and probably the next video, we'll be talking about when we're given three non-collinear points, 3 points not in a direct straight line, how to find the quadratic function whose graph passes through those points. We're going to first substitute x and y values, my ordered pairs, into that standard form. Ax squared plus bx plus c equals y. Simplify that down. Now this is going to produce three different equations. Once we have those three equations, we're going to solve just one of them, and it doesn't matter which one, for c. Isolate c on one side, everything else on the other. Once we know that, we're going to substitute the answer we received or produced in step 2 into the other two equations. Then we're going to have a system of equations, and we can solve that either by substitution or elimination. I tend to like elimination more, so you'll probably see that a little bit more, but I'll try to do both as we work our way through here. Sounds confusing. Let's work through one example. We'll go slowly and see how we do. Our first step is to substitute my ordered pair into ax squared plus bx plus c equals y. Doing so, I put 2 in for x in my first case, 3 in for y, so I'll have a times 2 squared plus b times 2 plus c equals 3. Simplifying that down, 2 squared is 4, so I have 4a plus 2b plus c equals 3. So far, so good. Now we're going to move on to my next ordered pair of 3 and 13. Substituting that in, I will have a times 3 squared plus b times 3 plus c equals 13. Simplifying, 3 squared is 9. I have 9a plus 3b plus c equals 13. And lastly, we'll do our third ordered pair of 4 and 29. Substituting in, I'll have a times 4 squared plus b times 4 plus c equals 29. Simplifying, 16a plus 4b plus c equals 29. Now, step 1 done. Substitute in 3 different ordered pairs into ax squared plus bx plus c equals y. Second step is to solve one of these 3 equations for c. We can do that. Now, it doesn't matter which equation you select. You can use either one, any of them, and I'm going to just do the first one here. So I'm going to subtract 4a and 2b from both sides. I'm left with c equals negative 4a minus 2b plus 3 as my value for c. Now, I take this in my third step and I put this expression and I'm going to substitute it in for c in these other 2 equations. Let's see how that looks. In my first equation, I will have 9a plus 3b minus 4a minus 2b plus 3 equals 13. Now I'm going to combine my like terms. 9a minus 4a is 5 A, 3b minus 2b is plus b, and I'm also going to at the same time subtract 3 from both sides, equals 10. Down to that equation in my first set. Now I'm going to do the same thing. In my second set, I'm just going to draw a little line here to keep things separate so you can see what we're doing. I will have 16a plus 4b minus 4a minus 2b plus 3 equals 29. Boy, I'm out of space there. Sorry about that. I hope you can read it. Combining like terms, 16 minus 4, I'll have 12a. 4 minus 2 plus 2b. Subtract 3 from both sides equals 26. So my two equations that I achieve in step 3 are 5a plus b equals 10 and 12a plus 2b equals 26. Now to move on to the elimination process, I'm going to draw a great big line here, and I'm going to star these two equations that we will be using. Now I like to line them up, put one under the other. So my two equations are 12a plus 2b equals 26 and 5a plus b equals 10. Now I need to look at my a's and my b's and see if one of those variables is going to be easier to eliminate than the other. In this case, I think if I multiply this bottom equation by -2, that will make my b's drop out. So my first equation stays the same. 12a plus 2b equals 26. I've done nothing to that equation. Now I'm going to take this -2 and use the distributive property and multiply both sides of my equation. -10a minus 2b equals -20. Now I can add the two equations together. 12a minus 10a is 2a. 2b minus 2b, eliminate, equal 26 minus 20 is 6. Divide both sides by 2. A equals 3. When I find A, B, or C, I tend to box them in so they stick out for me. Now I take this 3 and I can substitute it into either one of the two equations from step number 3. It doesn't matter which one. So if I put it in this first one, I'm going to have 5 times 3 plus b equals 10. 15 plus b equals 10. Subtract 15 from both sides. B equals -5. So far I know A and B. I need to determine C. So I take both these answers back to C equals. And let's see what we have. I'm just going to write that down here again. C equals -4a minus 2b plus 3. Substituting 3 and -5 in for A and B, C equals -4 times 3 minus 2 times -5 plus 3. C equals -12 plus 10 plus 3. C equals 1. Now that I know A, B, and C, I can substitute them back into the standardized form and generate the equation. 3 in for A, -5 in for B, 1 in for C. So we'll have 3a. How about 3x? Sorry about that. Let me get an eraser here. And go back. We'll have, how about 3x squared minus 5x plus 1 equals y. There is my general equation for a parabola that contains the points 2, 3, 313, and 429. It's very confusing. We're going to practice this a lot. Don't worry about it. You can go on to the next video at this point and we'll do a couple more examples and let you have a shot at doing a problem. And then in class the next time we'll meet, this is how we'll spend the majority of our time working on generating the equation for 3 noncollinear points. See you in the next video.